All right, welcome to day number 6. We're going to be talking about the rectangle, the rhombus, and the square. I included a little website there in the notes if you want to type that in sometime, take a look at it. It's just kind of a cool way to look at the various quadrilaterals. I'm going to do a separate video for the rectangle and for the rhombus and for the square. These are going to be pretty short little videos because I want to do the problems with you in class. So we're going to go through this little tiny section of notes for the rectangle, and then we'll come back together. Most of you have already encountered a rectangle somewhere in your education. Not sure where. Some of you start to recognize those as soon as kindergarten if you're going to a traditional school. But because I know we all did not have, the same kind of start, some of you saw them in preschool, some of you saw them later on. It doesn't really matter what. I'm here to tell you that a rectangle is a special parallelogram, okay? So it is a type of parallelogram. It has special properties. I'm going to try to write parallelogram inside that box. Wow, I made it. Okay. So all the things we knew about parallelograms, the opposite sides being equal, the opposite angles being equal, the next two angles being 180 and the diagonals being split into halves and the alternate interior angles, all that stuff is still there. But the rectangle, we call it kind of special because it has properties that the other quadrilaterals do not all have. Some of them do, some of them don't. And one of the things that the rectangle is known for is having 90 degrees in the corners. So hopefully you can see in the picture, I'm just going to highlight them in yellow. The parallelograms that we looked at didn't look like that. I mean, if you look at our parallelogram, these were not necessarily going to be 90. I guess it could be 90, but in that case, this would be a rectangle, a special type of parallelogram. So the other thing that is still there, the opposite sides. So you have the top and the bottom with the congruency marking. They're still the same length. Opposite angles. Opposite sides, excuse me. Opposite sides are still equal. And I think it helps to write this stuff down a little bit just because it makes it stick in your brain. Now here's the right and left opposite sides. They're still equal. Now take a look for just a second at the opposite angles, like this one and this one. See how they're both 90? So aren't our opposite angles still equal? So that's going to work no matter what in a rectangle. The only difference is that they're always going to be 90. What about the consecutive angles, or the angles that, the ones that are next to each other? Are they still adding up to 180? Let me write this down. I mean, they are, but let's see why. Let me just erase this one. And let's look at this one here and this one here. Like they're next to each other along the bottom. Well, they're both 90. If we add those up, those are still going to add up to 180. So in a sense, a rectangle is just a very special type of parallelogram. One of the things that happens with these diagonals, so I'm going to try to draw these diagonals in with my line tool since I do such a horrible job of freehanding. So there's a diagonal, and there's a diagonal. So it still does have two diagonals. That part hasn't changed. But the difference here is that the diagonals are going to be equal. They're going to be the same length. Whereas before, remember with our diagonals, remember they were bisected. You still had the halves, but from D to B, it was not the same as A to C. So those diagonals were not the same length, and that's because the corner angles were different. So now that we have 90s, what's happening is these diagonals are the same length. They're still doing this though. This is half, this is half. However, this is the interesting part. If the diagonals are the same length, then all these halves are the same length. Because when I divide the one, let's say the one diagonal was 10. If I were to divide that in half, this would be 5 and 5. But if the other diagonal is equal to it, because it's a rectangle, then it's also going to be 10. And these would be 5 and 5. Now, I just made that number up. That's not something like a problem you should have in your packet. But I was just trying to come up with diagonals that were the same length. And what happens when we split them into halves? They're going to have the same, excuse me, the same half length. So what we're getting ready to do is come down to the bottom. And what I want to draw your attention to real quick is that this picture, this is like, I want you to take your pencil before we come back together. I want you to number these. This is like problem number 1, number 2. See what I'm doing? We have like, I think it's like 6 problems down here. Let me make sure there's not any more on this page. Okay, so we're going to come back and do these 6 problems together, but they're all going to use this same triangle to the right. They're just going to be 6 separate, different problems. And then once we get done with number 1, we can erase it, and then we'll go on to number 2. Now, if you want to have 6 rectangle pictures, what you can do at this point is get out another sheet of paper, or maybe right in the margins, and you can draw that rectangle out if you would like to have 6 separate pictures. That's totally okay. All right, and then I think after that, we'll be starting our next video on the rhombus. Thanks, guys. Talk to you in a couple minutes.